Okay, so chapter 3 has 6 sections, and we will do the first 3 and then have a quiz, and then we'll do the next 3 and then have a test. So 3.1 through 3.3, quiz 3.4 through 3.6. Let's see. So the homework that I assigned today will be due we'll do this Sunday. It'll be due this Sunday, but that one will be put into semester 2 grades. Okay, all right. All right, so let's go. 3.1, we're going to start on page 252. We have exponential and logistic functions, okay? So we kind of talked about this in the P chapters. We talked about exponential functions already, right? Exponential function is a function that looks like this, b to the x. Okay, so it's something like y is equal to 5 times 2 to the x. This is an exponential function, okay? The most common misconception from you guys is that you guys miss this with this. If you have the variable in the base, this is called a what kind of function? This was an exponential function. This guy is called a power function, right? Y is equal to x to the 4th. Y is equal to 6 times x to the 8th, something like that. That's a power function, right? That's a power function. This is an exponential function. Okay, so there's a difference there. Okay, because in the exponential function, obviously the variable would be in the exponent. Hence, it is called the exponential function. Okay, all right. So if you look on page 252, there's a blue box there that shows you what the exponential function looks like. A times b to the x, where a is a non-zero, b is positive, and not equal to 1, right? Because if it was equal to 1, it would not be fun, right? Because you would have a function that looks like b, let's not do b, let's do a to the 1 to the x, where this is always going to be 1. So this becomes y is equal to a, right? That's not much of an exponential function. That's a constant function, right? So b cannot be 1, obviously. Okay. All right. So where b is called the base, okay? A is the initial value. The reason why it's the initial value is because in this part, if I go ahead and put x equals to 0 in here, this becomes a times b to the 0 power, and b to the 0 power is 1, so this becomes a. That's why a is called the initial value, because the value when x is equal to 0. Okay? All right. Example number 1. Let's go to example number 1. Example number 1, we have identifying exponential functions. F of x equal to 3 to the x is an exponential function, right? We're good. Okay. What is the initial value here? Y is equal to 3 to the x. The initial value is when x equal to 0, right? When x equal to 0, this is going to be equal to 1. So you don't see the initial value there because it's a 1, right? A times b to the x. Okay, that was a, b. G of x is equal to x to the minus 4th. And we already talked about this. This is a power function, right? A function, right? This is not an exponential function. Okay, C. H of x is equal to negative 2, 1.5 to the x. Okay, this is an exponential function with the initial value of negative 2. And this is just the base is 1.5. D 7 times e to the minus x. Okay, is this a power function? I mean, is this an exponential function? This is an exponential function, right? Because this is actually, yeah, this is minus x. Actually, this can be written as that, which is 7 times 1 over 2 to the x. Right? So this guy and this guy are the same thing. So obviously, yes, this is a power, this is an exponential function, right? So an exponential function. Then the last but not least, we have 5 times 6 to the pi. Five times 6 to the pi. And is this a power function? Is this an exponential function? This is not a function, right? This is just a number. 6 to the pi power is a number because pi is a number. Right? It's just a number, right? So this is not a function. There's no function here. Okay. All right, let's go to example number 2. Computing exponential function values for rational number input. So if f of x is equal to 2 to the x, this is example number 2. We have a, what is f of 4, f to the f of 4. This is the same as where x is, I'm going to put 4. 16, f of 0, 2 to the 0, 1. And this is the same as any exponential function. If you remember correctly, exponential functions look like this. It's always going to go when 0, it is 1, right? Because anything to the 0 power is always going to be 1. C, f to the minus 3. F to the minus 3 is going to be equal to 2 to the minus 3. 1 over 2 to the 3. 1 over 8. D, we're going to have f 1/2. 2 to the 1/2. Root 2. Right? And then last but not least, we have E, f to the negative 3 over 2, 2 to the negative 3 over 2. Okay, so this can be a little confusing. So let's kind of look at this guy here, right? Let's go ahead and look at this guy. And we're going to say this is going to be 2 to the 3rd minus 1/2. Okay? Because 3 times negative 1/2 is negative 3/2, right? So what is 2 to the 3rd? 2 to the 3rd is 8. Right? So it's going to be what? It's going to be 8 to negative 1 is 1 over 8. And we're going to take the square root of that. 1 over the square root of 8. 1 over 2 root 2. Okay. All right, so let's go flip the page, and we have one more. So let's get example number 3. Example number 3, we're gonna have, okay, well, now we have a difference between the, oh, never mind, okay. So determine the formulas for the exponential function of g of h, g and h, okay? So we have x, negative 2, negative 1, 0, 1, and 2. G and H. So we have G is 4/9. And then we're going to have 4/3. So from here to here, we multiplied it by 3. So from here to here, we're going to multiply it by 3 again. Multiply it by 3. Multiply by 3. 36. So what are we doing? So what is the initial value? Initial value is 4, right? So G of X is equal to 4 times, and every time we're doing a 3, we're multiplying by 3, right? 3 to the X, right? On H, we're gonna have, we have 128, 32. So we're up to here, we divided by 4. Go over here, we're gonna divide by 4 again. Divide by 4, divided by 4, 1/2. Again, the initial value is a value where X is equal to 0. So for H, we're gonna have, that's gonna be 8. And we're gonna go ahead and multiply every time as X goes up 1, we're gonna multiply or divide by 4th, 1 and 4, which is the same as multiplying it by that. Or you could rewrite this as that, okay? Okay, so that's that. On the green box, on the blue box on the bottom of page 254, go ahead and read that. This should be a review. We talked about the difference between an exponential growth, exponential decay. So G of X, and one on the one we just did, the G of X was a function that grew as X goes up, the value goes up. So it's a growth, whereas the H of X was the one that when you divided it by 4 every time. So it's an exponential decay, right? So if you remember this, in P, we had this is the growth curve. And then we had the decay curve that looked like this. So this would have been the decay curve. Okay, I'm having problems with that. So this is the decay curve. Okay, so what determines whether it's the growth or decay is the B value here, right? If the B here is greater than 1, as X goes up, you're gonna multiply it by something that's greater than 1, so it's gonna be a growth. Whereas if B is between 0 and 1, you're multiplying it by a fraction, or 1 over 4, 1 over 2, 1 over whatever it may be, you're just gonna decay away. So it's gonna, as X goes up, you're gonna go down, right? Obviously these both go through this point here, which is 1, again, because X, when X equals to 0, you're gonna get 1, okay? All right, so go ahead and read that. So that's the difference between exponential growth and decay, where there's a growth factor. B can become what would be called a growth factor when it's a growth curve, or a decay factor when it is a decay curve. Okay. All right, so let's go to example number 4 on page 256. Example number 4, it says, describe how to transform the graph. So we're gonna start with this graph, and and on A, we're gonna end up with a graph that looks like this. So where X was, I am putting in X minus 1. So what kind of transformation or translation is this? Caden?
I don't know.
Where X is, I'm gonna put X minus 1, right? So it's gonna be a to the left or to the right, okay?
Oh, isn't it to the right?
It's to the right, so it's 1 to the right, okay? That was good. B, we're gonna have 2 to the minus X. So where X is, I'm putting the minus X in, okay? So this is a mirror or reflection across the y-axis here, right? It's going to be the y-axis because where x is, you change 1 to minus x. If where y was, I put minus y, I would get what? I would get a reflection across the x-axis. And that's going to look like what? So I'm going to, if I start with this, and where y is, I put minus y, it's going to look like this, which means that my end result is going to be 2 to the x, like that, right? So that would be a reflection across the x-axis. Okay, a reflection across the x-axis would look like this. A reflection across the y-axis looks like this. C, we have 3e 2 to the x. So where I started with this, I'm going to divide this by 3, which gives me, now I can multiply 3 over, and I'm going to get this. So where y is, I put y over 3, which means that is a vertical stretch by 3. Okay. Okay, we're good with that. So that's example number 4. That was kind of just a review on how to transform functions. Okay, all right. Okay, so now we have the natural base E. Natural base E is a function that looks like AE to the X, right? This is a special kind of exponential function where the base is going to be E, okay? All right. On top of page 257, there is a definition of E. Okay, don't get too tied up or hung up about this. You don't need to know this right now. Okay, all right. But I mean, it's good to know. You don't have to know it, all right? E is equal to, the way we find E is equal to limit as x goes to infinity, 1 plus 1 over x times the x. That's how you find it. Does anybody know why we call the E E? Where the E comes from? Does anybody know? Nobody knows? All right. E was developed by a mathematician called Euler. Yes, this is pronounced Euler, not Euler. It's Euler's number, and that's where we get the E from, okay? A little bit of trivia. Okay, so if you look at the blue box in the middle of 257, it tells you stuff about the exponential function. Go ahead and read that for me. Should be all review. You should have no problem with that one. Okay, if there are no questions on that, let's go ahead and go to example number 5. Example number 5 says we're going to start with this function, and on A, we're going to end up with a function that looks like this. This is the same as that. You're dividing by 1/2. Which means that you are doing a horizontal shrink of 1/2. Okay. Now let's go to, that was A, and let's go to B. And in B, we are going to get E to the minus X. Again, where X was, we're going to put minus X. So again, this is a reflection across one of the axes. Since we are, wherever X is, I'm putting negative X, it is a reflection across the y-axis, okay? And then the last but not least, we have C, we have 3e to the x, and this is the same thing as before, since this is the same as f of x over 3 is equal to e to the x, where f of x, or y was, I'm putting, instead of y, I'm putting y over 3. So it's a vertical stretch of 3. Okay, so that's good. And we will stop right here for the first part.